Hello, welcome. We're in Algebra 1. We're still working on the first learning target about functions and its language. And we're going to begin today with, in fact, some language issues. Doing vocabulary is never exciting. It's not as fun as solving equations or making graphs of exciting things, but it is sometimes necessary. So we got some definitions here at the beginning. The first one is relation. And I'm going to go ahead and throw it all down there. A relation is a connection between an input variable, which we often think of as x, and an output variable, which we often think of as y. A relation is just, in fact, the thing that kind of connects the x to the y as an idea. I will be honest that the word relation is the least important word that we're doing today. Now, the next one is called domain. You likely have some experience with this from middle school. Who knows? Maybe not. The domain is the set of inputs in a relation. Now, I just said input was x, so it is the set of x's in a relation. If you're worried about the word set, don't be terribly scared by it. It has some funny business we're going to write down with some curly braces, but you'll see that in a minute. All right, and then the word range. Range is the opposite idea. It's the set of outputs in a relation. So the set of y's in a relation. Again, don't get frightened by the word set. It means some stuff with some curly braces. I'll talk about it when it comes up. Okay, first three terms. Now, we got some examples. Here's the first example. We've got a little chart, XY chart, and you're meant to give the domain and range of the relation. Now, the domain is the set of x values, so it's those numbers, 1, 4, 2, 1, 3. But, a couple things. First of all, it's a set, so it's inside curly braces. That's what those are intended to be. You can find those on your keyboard if you're interested. And then I wrote the numbers in order. I wrote 1, 2, 3, 4. Writing them in order is not mandatory, but it makes you look good, and it's good to look good. The other thing, though, is that the number 1 is only written once. That is important, even though, if you look at the circled group of x's, even though you might see it twice, you really only want to write it once. That is important. The thing about being in order, that's like good form, good idea. But writing the number 1 once, any kind of repetition, writing it just once, that is important. Okay, so then we got the range instead. Now that's the ones I circled in blue. And -4, 3, 9, 10, 11. Again, it's a set, so it's in those funky braces things. Good times. I wrote them in order. The order is not terribly important. In this case, there was nothing doubled up. So there was nothing to worry about 5 thing. You don't have to worry about cutting anyone out. And because of that, the range has 1, 2, 3, 4, 5 numbers in it, while the domain has only 1, 2, 3, 4 numbers in it. So they won't always be the same size. All right, that's the first example. Now, boom, second example. Here, the relation is given as some points. So you got the 0.23. You have the 0.30, the 0.52, the -1, 2. Now, I really recommend that you go ahead and begin, if you're given points, go ahead and start it by turning it into an XY table. Now, this is not mandatory, but if you're ever feeling confused, it's an incredibly good idea. So, you've got your points, make an XY table, little T-chart, maybe you call that. Then, from there, think about domains and ranges. So, the domain here, as a reminder, that's about the x's. So -1, 2, 3, and 5. Good times. Now, the range is about the y's. So it's 0, 2, and 3. Again, notice that the doubled up 2's on the y's only get written once. Like I said before on the last example, that is kind of a big deal. Again, notice we've got those braces going on. That is what indicates that it is a set. So we got set, We got numbers. We avoid repetition. That's important. And then, if you want to look cool, you make sure that they're in order. All right, second example. Now, here's the third example. Write the domain and range. Now, this one's different. We got a graph, and it's all the numbers kind of going off on that little curve thing. So the domain is the group of x's, and the x's are all the way kind of along there, because those are the x's that the graph hits. So it starts at -4, and it goes to 7. Because it's all the numbers between -4 and 7, not just the whole numbers, all the little decimals that you're thinking of and all the obnoxious fractions between -4 and 7. It's a lot of numbers. We can't possibly list them all. So we use this thing called set builder notation. Don't worry about the name. I'm going to write it down and then I'll help you read it. Okay. You should notice the braces, and then there's an x colon. The x colon part means x such that, and then 4 less than or equal to x less than or equal to 7. That means all the x's between 4 and 7, but also including 4 and 7. This business about the x colon bit, it means we're starting with the x's and we're telling you the rule about the x's that we're going to have. If that never makes sense to you, you can kind of just copy that formation, and that would probably not be the end of the world. That's not the key thing we're after here, right? We're trying 4 less than or equal to x less than or equal to 7. Now for the range was the set of y values. Starts up at 6, goes down to -3. So it's the y's between -3 and 6. Y such that -3 less than or equal to y less than or equal to 6. The y's in a sandwich, basically, between -3 and 6. Sandwich. Anyway, so that's example 3. I got one more here for you on domain and range. Here we've got another graph, but this time it is not a collection of things connecting stuff. It is just 5 dots. So the domain is the group of x's. And here I didn't draw a bar kind of connecting them because it's not all the numbers between them. It's just those x values. We got -5, we got 0, we got 7. So it's just -5, 0, 7. Here I went back to listing them like in example 1 and example 2. And that is because, in fact, it's just those x values, not the stuff in between them. Range, same basic idea, but instead you're looking at the y's. So it's all the y's that are hit. I drew a little dash on them. I also drew a dash on the ones that are points on the y-axis. Might be hard to see, but it's 1, it's 3, it's 8, and 9. Again, it's just those numbers, so we throw just those numbers in braces, and there we have a set. Okay, that's the first half. Now, there's this other idea called function. Now, function is quite possibly the most important vocabulary term from this entire first unit. Domain and range would be tied for second importance. So, it's a relation in which every member of the domain, which are the inputs, goes with exactly one member of the range, which are the outputs. So every input goes to exactly one output. Not 2, not 3, not 27 million. Every time you have an input, it goes to only one output. Now that's a great definition. And later when we start talking about story situations, that might totally be a great idea to go back to. But the truth is, when you're doing a table, or you're doing a set of points, or you're looking at a graph, while that definition is true, it might not be the easiest way to think about it. So I have these hints for you for those situations. The first hint is this. If you're looking at a table, a function does not have the same x value go to 2 different y values. So if you see the same x value listed twice, but it goes to different y values, it is not a function. In fact, it has what I call function fail at that point. But that term is a Wixorism. Okay, now, if you're looking at a graph, that's still true, what's written above, as well as the actual definition. But what a lot of people like to look at is this vertical line test, which means a function cannot be crossed twice by the same vertical line. This is a little bit harder to express, but it is also easier for students to remember once they actually learn it. So it's worth your time to try to fight for it at first. It will stay with you much easier than some other ideas. All right, a few more examples of what is a function and what is not. Here's example 5. Here we've got a table of values. Is it a function? You might recognize this is the same table of values in example 1, but I'm asking a different question now. All right, so we got this table of values. The first point is when x is 1, y is 3. When x is 4, y is 10. When x is 2, y is negative 4. When x is 1, y is 9. Hey, wait a minute. I thought when x was 1, it was supposed to be 3. So then you notice we've got something funky going on when x is 1. It goes to 2 different y values. It goes to 3 and 9, and that is why it is not a function. All right, so that's an example of a function not actually being a function. So it's not an example of a function. It's an example of a not function. Okay, next one, example 6. Is this a function? We've got a set of points. As I said before on the domain and ranges, I'm going to go ahead and recommend that you make a table out of it. Again, if you've got the idea, the table part is not mandatory, but it is incredibly smart to have that as a tool for when you're feeling confused. All right, is this a function? When x is 2, y is 3. When x is 3, y is 0. When x is 5, y is 2. When x is negative 1, y is 2. That actually totally works. That is a function. A lot of students get a little confused at first because they see a couple times that y is 2, but it's not really about the y values. It's about the x values not matching to different y values. If the y value is hit twice, that's fine, not a problem. Okay, example 7. We've got a graph. Again, you probably saw this back on example 3, but again, the question is different. Is this a function or not? Now, the way to check this is this. You draw a vertical line wherever you want, and if you can ever draw a vertical line that crosses that blue graph more than once, it is not a function. And in fact, every vertical line you could possibly draw on this graph, and I mean vertical means vertical, it would only cross that graph once, unless you weren't anywhere near it and it crossed it 0 times. But it would only cross it once, so that is a function. Next example, example 8. Here we've got the dots. Whatever. Vertical lines. Can you draw a vertical line that crosses the graph twice? Crosses the blue dots, in this case, twice. And the answer is yeah, you can. If you draw that vertical line, it crosses the blue dots twice. Now, I realize my line isn't beautifully vertical. That's a failure of the iPad system. I can't draw a perfectly straight line, which is kind of annoying in Algebra 1. But, so, pretend that red line I drew is totally vertical, and it does cross those dots twice, so that is not a function. All right, I hope you enjoyed this. I hope it helped you learn. Please come back to me with any questions if you have any. And I'll see you in class. Thanks.